primacy, do go over and have questions about primacy. Looks like majority is 2, 3, and 4, so we'll do those 3. 2. And all of those can be done in decimals. So for number 2, you can do that one of 3 ways. Use parentheses, add in a different variable, or make your x's capital, so I'll do that. Add in the slider, and then change this to -100. And our answer is -1/2, or -1/2. So it would be 1/4 times 4, which is 1. And then -6 times -1/2 is, oh, sorry, I put that, it was 9. I was just looking at the wrong thing. It was 9. I actually said that in third and sorry. Alright, for number 3, if I type in those points, they fall on the same vertical line, so the slope of that would be undefined. If using Desmos and not doing it algebraically or in the calculator, make sure you're use Desmos. And then number 4, you're finding your line of best fit. And then if you type in your y1 tilde mx1 plus b, you would get your line of best fit and use 3 decimals. So y equals 0.847, x minus 10.640. So then make sure you have that written down. We're going to go over the SOL answers. For 7E, this is really evaluating, but you're given domain or x values, and you have to find your y values. So if you put each x in, you get 82 and then 325. For SOL 8, this is all direct and inverse variation. So number 1 tells you it varies inversely. So you have to remember the equation for that. V equals K over W, or K equals V times w, you could put these in and see which one just makes the graph without knowing the equation, and that would be b. Or you could find your k value and use the equation to find b. And then using either your equation, putting x or w as 60 and solving it, or you can put that into Desmos and see where the two lines cross. And that would be about 2 days. And then number 2, this one's directly proportional. So if you were putting these answers into Desmos, these are lines, but your inverse and direct don't have addition in it, so not those. And then of these two, this is the more correct, because these would both give you lines that go through the origin, but to find the actual one, you would need to find your k value. So using your equations. Then in number 3, you're finding 2 other order pairs that would make this a direct variation. You can do that a couple different ways. One, find your y over x for each one, and then see which one matches, which were the first and the last. Or you could put all of these points in and see which one forms a line that goes through the origin. And then on to the next page. For number 4, you were looking for which equations were direct variation, which was just y equals 3x, y equals 1/5 x, and y equals -0.5x. 5 and 6, you were looking for the graph of a direct, which was the line that goes through the origin. Same thing for 6. And then for 7a, you had to find which of these 3 points would make a direct variation equation. They all had to have the same k value or fall in the same line, which would be 4, 16, 3, 12, and -2, -8.
I think it was for number 5, but I thought, wait, no, number 4. I thought it would be 1,500 equals y over x. So if you multiply the x by both sides, that would be y equals.
Yes, I missed that one. So that one also. Let me finish this and then we'll have that. Right. Or on the next page, 7b, you don't have to rewrite these order pairs, but it was talking about these ones. Which one will create an inverse? You're looking for if you multiply the x and y, you get the same thing, or if you were to graph them, they start to make that hyperbola, that curve, which would be -4,3, -6,2, and -112. Eight is doing a similar thing, but direct. Those 3 points would be 3.57 and 4.8 and 8. 9 and 10, you have the plot points that would make it a direct variation. So 9, you can put any of these 2 points, or you can plot them all and write any 2. And then 10 was the same, but it had more points. So again, and you had to choose 3 points. You could plot 3 points, any of those 3, or plot them all and put any 3. 11 was the start of a question, but it didn't actually ask the question until 12. So in 12, you had to find which equation would best work here. If you put the table in, you would see that it made the hyperbola, and it would be inverse, and then you have to figure out which one. Or you could find it algebraically, but E was the answer there. Today, which one would be that? 11, 12 was D. And then as well 9 was your line of best fit and your quadratic curve of best fit, which that part we haven't talked about yet. We're going to do that Thursday. So I didn't count some of those, but some of them based on just quadratics you should have been able to do them. So in this one, if you plotted or put in a table for all of these points, only one of these would have matched the best, and that would have been B. Number 2, this is your line of best fit, so you should have been able to find that and then find what the output would be when x is 5, which was B. 3, you didn't know how to find the quadratic curve of best fit, so this one didn't count. But if you knew the equation and found it, then your y value would be 2.33, about. And then on to the next page. Number 4, you're looking for, again, quadratic curve of best fit. If you didn't get this, make sure you write it down. Y equals 3x squared plus 2x minus 8. And then either putting your x value into that equation or finding the line where they cross, y would be 200. Number 5 is asking which best models this. I see it's making the U-shaped parabola, so it can't be linear, A or B, and it's facing down, so it would have to be B. Number 6 was another quadratic curve of best fit. So the equation was y equals 2x squared plus 77x plus 50. And then you could either use Desmos or put 13 in for all your x's to find $1,389. $1,389. And then on the last page, that was your line of best fit where you had to change the years starting with 0, going on, and your answer was B. Sorry, which one? I thought that's Alright, really quickly, I'm going to show some of these in Desmos. 7 I put in as the function and then put it in as a table and just found those two y values like that. All of your neighbors and direct, put those in and see if it makes a line or if it makes a hyperbola. And then for your 9, you could put some of those in and see which one would give you that quadratic curve of best fit. So today we're going to talk about how to find solutions, zeros, roots, x-intercepts of quadratics, but by factoring. So all of our factoring methods we have to keep in mind. And then the way we're going to do this is once we get some quadratic, we're going to factor it. If it's not already set equal to 0, do that. And then factor that, set the factors equal to 0, and then solve those to get our solutions. So, starting with this first one, how could I factor this? What factoring method could we use? Trinomial factoring, which type? That would be for your a doesn't equal 1, but here we have a equals 1. So then with our a equals 1, we're looking for two numbers that multiply to be 3, but add to be 4. 3 and 1. So go ahead and write your two sets of factors, x plus 3 and x plus 1. And then you're going to set each factor equal to 0. And solve both. And then when you get your final answers at the end, you're going to write these in curly brackets. What would our two solutions be? -3 and -1, least to greatest. And that would be your answer. Questions on that process before we try some others? I'll let you guys choose which other one we want to do, similar to A equals 1. If we want to see multiple, that's fine. 2 through 8, any of those we want to see, do go over. Have questions on. If not, we're going to jump to number 9. How could I factor this one? Could we use difference of squares here? No. So how else could we factor a binomial? Difference of squares is an option, but it won't work for this one because 8 isn't a perfect square and it has this extra x. Look through your notes, find your different factoring methods. Which one could we use to factor a binomial? If you are looking at me, you should be looking through your notes. Okay, so that would be GCF. If they both have a GCF and x is that GCF was left, x minus 8. So then we'd set both factors again equal to 0. When you get something like x minus a number, x plus a number, you don't have to show the work to solve it. You could just say this 0 is going to be what? -8. Positive 8, you'd be adding. And then the 0 is already given. It would be 0, 8. Now we'll get to some where you do have to show the work, but this one you don't necessarily have to do. Looking at number 10, 11, or 12, which of those do we want to see do go over and have questions on? How could we factor that one? Divide out the 30 and the x, GCF. What would be left? X plus 5. And then go ahead and set both factors equal to 0. This one, if we solve, we're still going to get 0. What would our two solutions be? 0, -5 and 0. Okay. Other questions like that, 11 or 12 that we want to see? 11. How can we factor that one? Say that again. DCF. What would our DCF be? 6x. What would be left? X minus 2. And then if we set these both equal to 0, what are our two solutions? 0 and 2. Okay, we could do 12 if you want to see that, but look at 13 through 16. Starting with 13, how would we factor that? Difference of squares, because these are both perfect square terms. So So that would mean you have two factors, two super factors. You're looking for what times what will give you x squared, what times what will give you 64, and then put a plus and put a minus. What would those two factors be?
X and 8 is -8.
X minus 8 and x plus 8. And if we set both of those equal to 0, what would our two solutions be? So you could write that as separate, or you could write them together as a plus minus b. Other questions in the section that we want to see, do go over, have questions about 16. How would we start to factor that? Or which method of factoring would we use? If it's a squares, what would our two factors be? 3x plus 7 and 3x minus 7. So with this, when we set each one equal to 0, actually solve this, because you're going to end up with a fraction. You could write it like what we just did, x equals plus or minus 7 over 3, or you can write them separately also. Let's move on to the next section. If there are others that we want to come back to, we'll do that. What's different about 17 through 26? They're not equal to 0. We have to make them equal to 0. So let's start with 17. How would I do that? Make that equal to 0. You're just moving it to the other side, rewriting it, and then doing whatever factoring method you need to. So how would I factor this one?
The two things that multiply to be c and pro is a, and that's going to be 7 minus 3.
So is your a equals 1 trinomial. You're looking for two numbers that multiply to be the last number, add to be the middle, and in this case that would be 7 and -3. Make your two factors. How would I write these two factors? So when I set both equal to 0, what would my two solutions be? So whatever your factors are, your zeros are always going to be the opposite of in this format. What others in 18 through 24 do we want to see, do you go over and have questions about?
20 and 19.
20 and 19. In 19, how would we solve that? Minus 7x. So then this one's going to be similar to 17, so I'm not going to continue that, but I'll let you do that on your own time. 20, how would we solve that? So you have to get rid of both of them. As a general rule, it doesn't matter if you move everything to the left or to the right, but I would say wherever the x squared term would be positive, move everything to that side. Again, this is another a equals 1 trinomial. Do we want to see the answers to either of these, not both? Which one? 24 we can do. In solving 24, how would we do that? Difference of squares, perfect squares, same thing. So those two factors would look like what?
14x minus 3.
Not
Or
4x.
4.
So then set both of those equal to 0. If you wanted to solve one of them, since you know they're going to be the same, that's fine. If you want to still solve both, that's also fine. Go ahead and solve that and tell me what your two solutions are. So it should be a fraction. There we go. Plus or minus 3/4, or you can put 3/4 and negative 3/4 and positive 3/4. Yes.
On the JLab, we had questions like this. I was wondering, is there a way we can do the plus and minus thing, like how we're writing it right now? Like, answer the question.
I'd have to look at that specific question. If it has like places to put it, just write both answers. I don't think there's a place, but I'd have to double check it. Alright, moving on to the next section. So all the ones that we were just doing were all of the different factoring methods besides this one. GCF, difference of squares, a equals 1. We didn't do grouping the 4 terms, but we're going to do that in some of these. So let's start with example 1. What would be our first step?
12 times.
Okay. We can do that, but does it have a GCF? Yes, so do that first. Check for GCF first. What would our GCF be? And if I divide that out, what's left? So even though the inside is the same as what we were just doing, I'm just going to show you what happens with 3 again. So we're looking for two numbers that multiply to be negative 4 but add to be 3. What would those two numbers be? Would it be negative 4 and positive 1? Would that give us positive 3? 4 and negative 1. So same numbers, but just switch the signs. I wrote the same thing. So x plus 4 and x minus 1. And then when you set everything equal to 0, the 3 can't equal 0. It doesn't have something to solve. So we just don't include that part. And we just write the other two, which would be what? X equals negative 4 and positive 1. Correct. So if you have a GCF that's not a variable, still make it part of your factored answer, but it's not going to be part of your solutions answer. Example 2 is going to be similar, but let's look at example 3. How would we start that? Do we have a GCF? No. So then we are using our true to life 8 doesn't equal 1 trinomial. What's our first step after GCF? Multiply 2 and negative 5.
Negative 10 and 5 minus 2 equals b.
Find the two factors that would add to be b. 5 and negative 2 work. rewrite this into 4 terms. If you want to switch those so that the 2's go together and the 5's go together, that's also fine. Split it down the middle. Find the GCF of both sides. What would it be of the left side? If you put the 2's together, it would be 2, but in my case, it would just be x, leaving 2x plus 5. And then GCF of my last 2, -1. If you put the 5's together, then it would have been -5 or 5. Which will leave us with the 2x plus 5. Set those both, rewrite your factors first. Then set them both equal to 0. Find your 2 solutions. And when you get your decimals, if you have nice decimals fractions, you can put it as a decimal, but if you get something with a repeating decimal, leave it as a fraction. On this page, 2 and 4 are going to be more like example 1 and 2, but we could do those if you so choose. Example 4 and 3 and 4 are more like what we just did. Which of those do we want to see you go over and have questions about? None, go on to the next page. (11) through 14 are the ones that don't equal 0 and are going to be similar to what we just did. Are any of those, or 5 through 10? Do you want to see any of those? 14. Okay. In 14, how would I get this to equal 0? Say that one more time.
Subtract x squared
So that would give us 4x squared plus 7x minus 2 equals 0. And then do we want to see this factored out?
You have 4x.
We subtracted x squared. I got squared minus x squared. If we don't want to see this factored out, we're going to go on to the next page. So go ahead to the next page. So there are other ways to solve quadratics algebraically, but we are not going to talk about some of those. But you may see or hear of them, solving by square roots, solving using the quadratic formula. Those are mainly the two. All of the factoring that we did and getting solutions at the end meant it could have been done on the calculator in the graph. So we're going to talk about how to find them in the graph for a little bit, and then one last thing, and then you guys will have time to practice. So part of this we've seen before. Quadratic roots are the points at which the parabola intersects the x-axis, also called zeros, x-intercepts, solutions. I said that backwards, anyway. And then you have 1 of 3 options with quadratics. You could have 2 solutions. All of the factoring things that we've been doing that had 2 different numbers, those all would have been graphed and crossed the x-axis 2 different places, plus you, to have 2 solutions. We haven't solved many that had 1, but if it just touched or if it just touched the x-axis once, that would be one solution. And then if it doesn't cross it at all, so that would mean it can't be factored. It would have to be solved by quadratic formula / there are imaginary numbers there that we're not doing in this class. That's how you would get a no solution. So for your characteristics of quadratics, you not only need the vertex, axis of symmetry, domain, and range, but also your zeros. And that can be done from a graph or by factoring. Make sure you have the rough sketch of these 3 also. And then we're going to do a couple of these. Anyone still need this? So for example 1, we're going to put that into our calculator. The same thing would work on Desmos. And we're going to go into the table, so second graph. And you could find your vertex axis symmetry by hand, or if you're looking at your y values, find where your y values repeat, and then keep looking through that list until your y values no longer repeat and it's in the middle of the repeating y values. So where would the middle of all of those be? Where do your y values no longer repeat? At -9. So you would write this, that would be your vertex, -2, -9 in the middle. You can fill out your x's and then your y's from the table. So if I get half of it, because it's symmetric, the other half should be the same. So -9, -8, -5, 0. And then it repeats. Go ahead and graph all of those points. Once you get half of it, the other should just repeat, but 1 away. So it should look something like this. Mine looks a little bit like a V. It should be more U-shaped, but I'm going to highlight the X and Y axes just so we can see it up here a little bit better. How many solutions do we have? 2. What are they? -5 and 1. And you can look at that from the graph or from the table. Or this one, because we have 2 solutions, it could have been factored. You could also find them in the calculator by going into the graph, looking to see do they fall on whole number points, or if you wanted to double check, use your second trace to find your zeros, and then do that process. If you want to see that done on the calculator, let me know. We're going to skip number 2, move on to number 3, and go ahead and put that in your calculator. Again, in your table, find where your y values repeat and find the middle.
So you have to show negative because mine only stops at 0.
Did you go up or go down?
Well, if I go up, it's up.
Where is the middle?
-4.
1, -2. Should be here. So at 1, -2, and then fill out the rest. -3, -6, -11. If you want to plot the 11s, you can. This is a 10 by 10, so it'll just be one on the graph. If you would rather just focus on the ones that are on the graph, that's also fine. It should look something like this. How many solutions does this have?
1.
Does it cross or touch the x-axis? So it doesn't have any. No solution. You write that like this. On the next page, you're going to ignore the stuff about the discriminant. We're not talking about that this year. Are there any other graphs that we want to see to go over before we do this last page? Five. Okay, let's do 5 on the back. And then you can go ahead and graph that or put it in your table and find that. Where is the middle? Where's your vertex?
0, 0, 9.
And then the rest of your y values, we have 8, 5, 0. So without graphing this, I know I have how many solutions? 2. There are 2 places where I have x-intercepts. But I could graph it quickly. What would those 2 solutions be? So if I had factored this, I would have to factor out the negative as a GCF, and then I'd have the difference of squares, which would give me the plus and the negative. 3. Look at the very last page. not only do you have to be able to find your zeros from your graph algebraically and graphically, but also be able to write the equation from your factors. So we'll do two of these. For the first one, you have to find what your x-intercepts are. What are those two x-intercepts?
-4, 0.
-4. I'm just going to put x equals -4, but that would be the order pair. And then the other one?
2.
2. So then we're going to write this as its factored form. So I'm going to have x and 4 in here. Is that going to be plus or minus? Plus. And the reason that is if I were to set this equal to 0 and solve it, I would get the opposite, which is what I'm looking for. So whatever the actual 0 x-intercept is, your factored version is the opposite of that, and vice versa. So then, for x equals 2, how do I write that factor?
X
Minus 2. Then we're going to go back to previous knowledge to distribute this. So x times x would give us x squared. And then we have negative 2x plus 4x minus 8. Combine like terms, what would that give us? 2x. X squared plus 2x minus 8. And if I graph this on top of the factors, it should overlap. And that's how you know it would be the same. Questions on that before we do one more? I'll let you guys choose 2, 3, or 4. Which of those we want to see do go over? 2. Okay. So in number 2, what are the solutions there? Look closely. There are 2. 7 and 8. How would I write those two factors? X minus 7 and x minus 8. It doesn't matter which one you put first. And then if we distribute this, y equals that would be the final answer. So here we have 7x minus 8x plus, or different things, 56. Multiplying the 7 and the negative 7. Do we have any questions at all on how to find our zeros from factoring, from the graph, or how to write the equations from the factors? And then for the remainder of class, you guys can be working on any of the following. Notes from this, or problems we didn't go over in this set of notes. Delta Math us due on Friday your zeros by factoring, what we just did, characteristics of exponential functions, or characteristics of quadratics. All of those are due on Friday, or your JLabs. So be working on something